Hi everyone. I think you know me by now, but I'm very fun. I'm a postdoctoral researcher and a digital features fellow for the past 3 years here at KTH in speech, music, and hearing. What I'm going to talk about today is what I did during my postdoc, which is using large language models for creating conversational companion robots for older adults. And while doing that, we discovered the challenges and also developed some solutions to overcome them. So now imagine yourself 30, 40 years from now, alone in your house, your friends visiting from time to time, and as well as your family, but you're alone most of the time and feeling lonely. And for that reason, we wanted to decrease this loneliness by putting a robot there, a conversation robot that can talk to you every day, that will listen to you, that will provide social and emotional support. But this, in the past, was not possible. The reason was that this day-to-day conversations are actually, can be about any topic, can be about anything and everything. And it can, continue from previous conversations as well, which is a very difficult topic, up until very recently, up until 2 years ago, when I actually started my postdoc, when the large language models started coming out. But before that, that was Wizard of Oz, whereas there was a person behind the robot, and you would think that the robot was fully autonomous, or there were task-based systems, like they will provide you daily reminders, but you need to know your schedule and everything beforehand. But it wasn't this everyday conversations that you could have. So we said, okay, perfect. We have the large language models. We're just going to put it on a robot and hope for the best, right? Because this previously has not been explored. There was no robots with conversational robots with large language models, especially not for older adults for these day-to-day open domain conversations. And but when you're making robots for older adults, you can't just like make a robot and say, there you go, use this. It's going to be helping you with your loneliness in your everyday life. It's perfect for you. No, because we don't know what they want. We don't know what they need, their expectations and preferences. So that's why we can have this participatory design approach to involve them into the design process of this robot, so that we can iteratively develop the robot and learn from their feedback what they need, what they want, and so on. So we first had for 6 Swedish-speaking older adults come into here. So that we can first have these preliminary interviews, more like open-ended interviews with them, and they can talk to the robot back then in English. And this was back in October 2020, 2022, sorry. And then they would 2020 would be too early, 2022, and they would talk to the robot, and we had several challenges. But then we developed the robot a bit further and like iteratively, not too much putting everything on top, because we don't know how these large language models are going to be performing. So we want to actually see how they will. So we do these small iterative changes to the robot. And then we evaluate it again with 28 older adults using these participatory design workshops, where we ask them first about their expectations, what they want from robots in certain daily life scenarios, and then have them talk with the robot for 7 minutes. And then we gave them questionnaires, really thorough questionnaires on what they thought about this based on the literature, as well as had these semi-structured interviews with them to understand deeper into their feedback with these robots. So let's talk about these design scenarios first. So what were they? So for instance, we gave them this on the very right. You can see that the person is going to visit their family, and it comes back home after to talk with the robot. And what do you say in this case? What do you talk with the robot? Do you want to talk with the robot? What do you want the robot to ask you, and so on? And in the second case, like I showed before, you're feeling lonely and you're home. What would you want to have the robot? What type of conversation would you want the robot? And we had also these questions from these user perception user perception Almir model, for instance, and then we made them more open-ended by asking, why do you think that? What would you like? How would you do this? And so they had these very discussions between them that led to anywhere they would go. And then on the third scenario is that you're, for instance, receiving bad news on the phone, and what would you want the robot to say? And then receiving good news, like your daughter being pregnant, and waking up to a new day. What do you talk? And finally, when your friends come over, what do you want the robot to say? I'm gonna so based on these discussions, we analyze it thematically, and to understand, to come up with certain recommendations to have these to what these robots should have, these companion robots should have, and how to make them with foundation models. And the paper here in Cure just got published last week. You can find it even more detail. I'm going to summarize the findings and the foundation model suggestions, but there is more into there. I would suggest if you want to make these robots to look into that. For instance, first of all, people want the robot to actively listen when they're alone with the robot. So the robot should ask follow-up questions. The robot should be like trying to make them think positively, trying to like facilitate conversations and so on, but only when they're with the robot. And how can you do that with foundation models? First of all, you need to understand that you're alone with the user, that there's no person around you. And one way to do that, it could be that the topic that you're discussing could be something that's personal, that the person has started, that you might understand it simply from LLMs, by large language models, simply LLMs, to discuss this topic. Another way is to detect activities and locations and events through using multimodal foundation models to understand further into the context of what you're having right now. And let's say you do, and you are in fact alone with the user. So how do you go about this active listening? So you can do prompting, and there's going to be a lot of prompting in this talk, but this is also what we did, because that's a first way to start. If things works with prompting, there's no way to add more elements in it, because the more elements you add, the more time it's going to take for the model to give answers and so on. So it's easier to do it through prompting at first. And this is also what we did to analyze how LLMs perform. Another way, also done in literature, is to do fine-tuning on human data sets to human-human conversations, and how do, for instance, therapists talk with humans, with older adults, how do their caretakers talk with older adults. And this was actually used in previous work that was conducted more or less the same time as us with older adults. And another way is also to give back channeling, so just to give nods, say yes, and so on, to make the user feel that they're being listened. Now, when we go to the social settings, and then you have the friends around, then they don't want the robot to be involved in a conversation. You say you must be able to register, but to be able to talk about it, to reminisce about it later, to debrief up with the robot, to understand what you talk with your family and your friends. But you don't want the robot to be participant in the conversation, because that's your family time, that's your friend's time, it's not the robot time. And this requires that the robot remembers certain things, and to be able to like understand what is important in the current context. So you would need to like summarize. You need to either do prompts, or you can do these retro like augmentation methods, or RAG methods, to generate these summaries from this data that you're collecting, and use that to store that in a knowledge base to remember later, especially with attention mechanisms, because the more you store data, the more it's going to get bigger, and you're not going to be able to tell what was important and what was not. Another thing they wanted the robot, and this is of course my area, is personalization. They wanted the robot to learn, but not saying like thumbs up, thumbs down, reinforcement learning from human feedback type of learn, but learn by itself, by talking. You should not tell the robot, you should learn this, you should not learn this. The robot should be able to understand or like learn from your conversations, and to be able to remember it later and give advice about your family, or give recommendations for instance, a good film, or other things, or your daily reminders and so on. It needs to be able to be personalized for you to continuously interact with that robot in a day-to-day life. This one way to do this, as I said, it's not reinforcement learning from human feedback, where it needs explicit feedback, but lifelong continual learning. So what is continual learning is that you learn from new data over time, but you do not forget the previously learned information, which is called catastrophic forgetting. So, which is typical in machine learning systems, that if you fine tune a data set, or if you train again the model that you have, you will actually forget the information. And lifelong or continual learning methods try to adjust so that it learns self-supervised, unsupervised, or supervised ways from data. And to refer facts and to learn facts in a conversation, again, you can use prompting. But for instance, you can store information and say, use this information that you previously learned in a conversation. We also did that. And or other similar to other things that I mentioned, retrieval augmentation methods and fine-tuning to understand what is important in a conversation. And finally, you need a semantic understanding to be able to for instance, help with the person in their houses to make a cake. And then you need to be able to know where if you have, for instance, a manipulator, know where the equipments are, you can take them and so on. And this will be personal to that person's house. So it's not just a conversation, it could be expanded further for semantic understanding. But with personalization, of course, comes the issue of privacy. So if you have everything that you're telling the robot, you don't want anyone else to have access to your robot. And of course, as one person said, it would be very strange if you tell about your whole life and then someone can access it, right? You don't want that. How can you overcome that? Is to do user recognition. So this was actually what I did during my PhD. If you want an algorithm, I can definitely give you one. But you can't just do face recognition for older adults, because actually face recognition face recognition systems do not work well on older adults because of the lack of data in their training systems, and also the wrinkles that cause problems. Also, other lighting issues or other types of blurs and so on could cause problems. And you also want these people to be learned over time, right? You might have guests coming in. You want the robot to learn them without you teaching the robot hundreds of pictures of this person. And to also find called incremental learning. And if you also want the robot to recognize you when you wear sunglasses or have a haircut, that is called online learning. The robot should adapt to you and recognize. And now that, let's say, we have a person recognized, then we're sharing the data, but we want one way to do this actually to have onboard systems, but with large language models, because they're so large, you can't have these things on the robot itself with CPUs or the GPUs that the robots generally have. So what you could have is anonymize that data to send to the cloud with the privacy preserving machine learning algorithms, and also actually use them as the large language model base themselves. But even if you do, there might be a certain time that the person wants you to forget the data. It's like, oh no, don't remember that, forget it, yeah? Delete it. And in that case, you might need to have deletion of the information, and this is also possible with machine learning, called machine or knowledge learning. Now we have the information. We are very secure and everything. We're personalized. Now we're going to give information and daily reminders. We're going to remind them that how is the weather today? Or do you want to hear the latest news? Or you have an appointment coming up today, right? But when we're doing that, we need to overcome hallucinations, because these models, what they do is all about hallucinations. I mean, I hear sometimes people say, oh, large language models hallucinate. Yes, of course, that's the whole point of them. They are supposed to generate an answer that is the most likely response to what you gave, your input. And of course, some of those times, it's not the right answer. And that's what is called the hallucination. So I'm going to come back to how to overcome these later, but it's really important, especially for older adults, because you cannot give them, for instance, for health-related issues, wrong information that could be quite serious. Another thing is that you can have these knowledge bases that you store the information in, especially for personalization. And then you can have these fact-checking mechanisms with this knowledge base so that you're not generating stuff that is not true. Again, lifelong learning can help you learn this new information, to give the daily reminders, as well as internet access, which by the time we were doing this experiment, we did not have it because it was GPT 3.5, the DaVinci 3 model. And one more important thing is that when you're giving recommendations to the person, or you need to be able to make them explainable, right? So that the person can understand what is reason behind this recommendation. And that is also possible through prompting or fine-tuning for these models. And if you have adversarial behavior, if you have adversarial users that want to teach a robot incorrect or inappropriate things, then you should also have these mechanisms to fight against these adversarial users. I'm not talking about older adults, but it could be that if the robot gets used by other people, for instance. So there are two types of older adults. And when people always think older adults, they're like, oh, yeah, 65 and older. And that's what we also thought. But the thing is, there are these that we had from 66 to 86, and they were saying, oh no, this robot is not that useful for me, but for my mom, it will be great, right? Because that mom is not the one that's going out of the house, because these are the people, they're the healthy older adults. They go to sports, they go out, they see friends. They don't need that robot as much as the people that are actually quite older or with cognitive disabilities or with Alzheimer's disease that would need the robot. But when they do, if they do, they want the robot to not just talk to them, but actually connect them with people, with their friends or with new people or their family. And for that, you need the models, that foundation models that can actually give tool usage to access to social media or phones for reaching out to the people. And also, as I said, like these models can help enrich the communication and cognitive skills of these older adults by either like prompting or fine-tuning, or for instance, talking about what is on the TV. So this is something that for us and for older adults, it comes as easy to do because you see something on the TV and talk about it, right? But it's so difficult for these models because one, they need vision language models, so these multimodal content foundation models, and two, they need to actually remember what was on the previous TV. This is a TV series, for instance, and then actually refer back to it, understand that this is TV and it's not live people, and it's a very difficult problem. But for older adult, it is important, so it's worth investigating. And one final thing they wanted was that the robot to be empathetic. The robot shouldn't, it's not about, they said, like simply sharing feelings, being able to show happy. So it's not just listening, but also responding happily, responding sadly, really showing its own feelings as well. And that's why you need to have these empathetical agents. And we also did that in our study through prompting. But there's also ways to do it through fine-tuning or doing multimodal effect recognition so that you can actually respond to the people's effective responses. One thing that we were using Amazon Polly in the robot, and people said that the voice was very dull. And we had actually decreased the speed down to 80% so that it could be an easy interaction with the older adults. Turns out we made a very dull robot, and they were really not happy about that. They were like, no, this sounds dull. This is not what I want to talk to every day. So you might need these emotional voice conversion systems that, for instance, 11 Labs is doing, or other systems are also doing. Now GPT-4o is also doing it, that it actually reacts according to the mood of the sentence, for instance. And not just your voice, but also your facial expressions and gestures, if you are not just a head like Farhad, but you need to be all according to the context of the conversation. So, as I said, I kind of hinted, we had a Farhad robot in this study that we had for these older adults. And then for speech recognition, we use Google, which is one of the most common methods. And then for dialogue manager, we use a GPT 3.5 and combine it with the Amazon Polly for text-to-speech, and then we have a fully autonomous robot. But again, as I said, we didn't know how this was going to turn out. We just wanted to explore how the large language models can perform and overcome their challenges along the way that we do. So we had in the preliminary interactions, for instance, these types of interactions.
Hello, I am Furpat, the personalized companion robot. What is your name?
My name is Elizabeth.
Nice to meet you, Elizabeth. What do you like to do?
Oh, I like to have a nice chat with you.
That's great. I'd love to chat too. Do you have any hobbies?
I read a lot, and I also like to pick berries.
So as you can see, like the robot is actually leading the conversation. At the beginning, we had an agent that was based on what the state-of-the-art prompts were doing it to learn more about the person, it's the first interaction, and so on. But it turned out to be a very dull agent. So that we actually changed the persona to be more empathetic, more understanding, more active listening. But I mean, this looks good, right? Like, I mean, everything's worked fine. This is fully autonomous. We just start the interaction. We give a participant ID, start the interaction, and then participant can say goodbye and end the interaction. That's it. Perfect. Yeah, maybe not.
But my favorite is probably broccoli. What about you?
Yes, I like broccoli too. I use broccoli very often for a soup. And I like.
Yes.
And I like
broccoli
to.
is a great vegetable to use in cooking.
Yes,
Thanks for sharing that with me.
I like to cook it in steam. It's better to cook it in steam. Do you
Yes.
use?
Steaming is a great way to cook broccoli.
Oh.
Thanks for sharing that with me.
So as you can see, the person gets interrupted a lot. And actually at the beginning, that was on average 14 times that it was being interrupted, which is pretty terrible, especially if you're using that second language that you probably haven't used for a while and you're trying to like make this conversation with the robot and the robot keeps on interrupting you. So turn taking is in fact a big issue. So how can you overcome this? How can you do this? By the way, the GPT-3, as you probably noticed, the 3.5 response time was 2 to 3 seconds, which, you know, it sounds little, but as you probably noticed, there is a huge gap. And even for older adults, there was quite noticeable gap. So they were trying to overcome and like take the stage. And in the next, the participatory design workshops, actually, we asked people if they actually figured out it was slow, and 46%, almost 50% said, yeah, the robot is actually slow. So how can we overcome this? So this is actually what I'm going to work next, but like with detecting the turns, but to give you a snippet, so you can understand the dialogue context. So you can see if if the person is about to continue the conversation, or you can try to understand it from the person's speech prosody and gaze to these multimodal cues that give you away that they want to take the turn, they want to actually speak, as well as like gestures and facial expressions like this, right? But that's great, we detected the turn, but we still need to make it a bit faster so it feels natural. So one way to do this, of course, you can use a smaller model, but that means you're gonna have worse interactions because you're not going to be able to talk about everything. And the other thing is what we were doing was not streaming. We were getting the response from GPT-3.5 and then giving that to the text-to-speech. Whereas you could stream, as you write, for instance, with ChatGPT, that it comes one word by word. But then if a person interrupts in between, then your response might have completely changed. So that's something you should definitely keep in mind. Or you can have these progressive responses where like, oh, the person is saying this, I might be able to say this in response, and then you can choose the most likely one that in the end while the person is speaking. And you can also use, of course, like instead of these smaller models, use quantization methods like LoRa to make things faster, or use the summarization of your dialogue history. So instead of feeding the whole dialogue history to the robot to give a response, you can summarize. But summarization is not very good in large language models, so it can actually turn out to be completely wrong what you actually had in the history. You need to be very careful with that. And one more thing, well, yes, there's still gonna be silence. It's not gonna be completely gone. How you can feel it is that you can either say like, let me think about it. and then continue, or like do these back channeling and like, yeah, yes, yes, and so on, so that the person can actually feel like this is a natural conversation. Another thing actually quite connected to that is that while we were doing the experiments, it was right around the time ChatGPT started. So our responses was getting quite empty responses, because you're sending the server for input, and it needs to send you back. While I was testing the robot before ChatGPT came out, it was quite fast. Whereas during that time, it would just not give a response because it was so busy, the server. So basically, this would happen.
There is Japanese author who writes.
Could you repeat that, please?
There is a Japanese author who have written.
Could you repeat that, please?
No.
There's a Japanese author who have written.
I'm sorry, I didn't understand you.
Sorry.
So the thing is, unfortunately, we were feeling these empty responses, weren't expecting there's going to be a lot. With these, I didn't understand you, could you repeat that, please? And when it's happened so many times, then it becomes really frustrating, right? But it wasn't only the case that it was the empty responses that were giving the repetitive responses. It was also the use 3.5 itself.
In nature.
That sounds really nice. I love nature too.
Wood with a lot of what is called moss.
That sounds really nice. I love nature too.
Want to know what I see in
Oh.
nature? And I'm also.
That sounds great. I love nature too.
So those responses can actually were on average 12 times in an interaction that the robot was saying the same thing at the beginning. This preliminary interactions. The one we change the persona and like make the system more empathetic and nicer, more listening and so on. These were thankfully much less, but it still happened. So how can you overcome that? So the empty responses, you can always use an onboard model, like the available open source models like Llama 3 or Mistral. And of course, again, you need high computational power, and that doesn't exist on robots. So another way is to instead of like asking for, could you repeat that, please? Or like, I don't understand, you could say, oh, could you tell me more about that? Could you explain further? And so you can still catch up with what you missed, especially even if you have speech recognition errors and so on, but you don't annoy the hell of the user. And the repetitive responses that the model itself is giving you can increase the frequency penalty so that it doesn't do that, hopefully, or you can prompt to do rephrasing for if you're coming across the same template again in the response, then you have to rephrase the sentence so it sounds a bit more different. Because the reason we think that kind of happened is because it's getting conditioned on its own response. Like it is getting a response. I love nature too generates a response from the user, and the response seems to be nice as well. So it's like, yeah, that's a good response. I'll keep on using it. Of course, it's annoying when it's done that, right? Other ways to do that, you can do like sampling, unlikelihood training, batch first decoding, or like reinforcement learning from human feedback to understand whether the response you're giving is actually annoying or not. And that doesn't actually have to be thumbs up, thumbs down, because you can maybe use your person's emotions to understand if they're getting frustrated. I'm going to come to that as well. Another challenge was to create conversations that are interesting for older adults. So these people have seen a lot through their lives, and you have put the robot that wants to talk to them.
I love the cinema too. What's your favorite movie?
I don't think I have one favorite movie.
What is your favorite book?
I have no favorite book. There is not. I have read thousands of books. I have not one favorite.
Is there anything else you would like to talk about?
Yeah, do you read the daily papers? I like to talk about books. But I don't think you have read the same kind of books as I have done.
So the initial personality, like I said, it was based on the state of the art where you need to learn about the person. But those conversations are actually like, trained on like young adults who, have a favorite book, have a favorite movie. Doesn't work with an older adults. You want to have them like conversations about their memories, about their childhood, about their families and so on. And that's what we did in the second part of the interaction. So we improved the persona to ask about those kind of things instead of movies and books and their favorites, hobbies, and so on. And still, we had 70% of the conversations in the second part of with the 28 older adults, conversations informal and superficial talk. So only 25% was hobbies. So we still got a bit better than just hobbies and favorite books and so on. But it could be also because this is the first ever conversation you have with a robot, not just with a person as well, with that robot. So of course you're gonna try to get to know it, try to ask some questions about the robot and so on. So it's not gonna be something deep, but there were also people talk about politics and UFOs. So there's interesting things that could come up in a conversation, especially if you have these long-term interactions. So how can you make these richer and more personalized interactions rather than these shallow, what's your favorite book type of questions? So you can increase the topic variety by presence penalty. So you can try to decrease what is previously asked, and the temperature. Also, fine-tuning on conversations that people have with these older adults can help. And ensemble large language models. For instance, you can give the response for one large language model to another to try to find different answers and decide accordingly. And when we actually looked at the asked the people, so do you think the robot has a personality? And they're like, no. Only 10% thought that the robot had something. So you can try to improve that by having these follow-up questions and having its own personality, to have it give a character, a background story, and emotions and personality, which I actually worked on during my internship at Disney Research. So there, they also really believe in this character. They really work on this character thing, and it's important for this believability aspect for their agents. And you can also, as we talked about, personalized interactions so that over time you remember their conversations and you don't ask the same things over and over again. And one of the other challenges was the language barrier, right? So we made the first interactions in English. And Swedish people can speak very good English. But with age, if you do not use the language quite often, you will decrease, right? You're not going to be able to be talking as well as your native tongue in your second language. So, and that could make you quite shy, and especially if the robot has these turn-taking problems that is trying to get the floor of you, and you're trying to talk faster and cannot, make a response, then you will be not wanting to talk to the robot in the first place. For instance, like
What do
this.
you like to do for fun?
Prep. Alltså det står helt stilla. I like to see a movie.
Christina, you like to go to the circus. Do you have a favorite?
So that Swedish part was unfortunately understood by the speech recognition, was thinking that the person speaking English as a circus, and the conversation went somewhere else, and then the person was like, I don't know how this happened. So they asked the experimenter to take over and talk for them, and they were actually quite amazed after the experimenter was talking to them in English. That's why, and we had feedback, more or less similar feedback from 4 out of 6 older adults saying that in the first study that the robots should speak in Swedish if we're going to have this robot in our houses. But we did that, and the conversations were quite smooth afterwards. But there were also cases that we did not expect, like
Jag
this.
vill höra Amazing Grace.
Amazing Grace sjunger. Amazing Grace, how sweet the sound that's a bed of richly comedy. He once was lost, but now I am found. Was blind, but now you see.
Nej.
So this
Du
is
sjöng
Swedish.
inte, du pratade.
One is it's I don't know if you saw, but the new GPT-4 supposedly can sing. Not that well, but it was even worse back then. There was no singing; it was talking. But also talking an English song with a Swedish accent made even things worse. And sometimes it would actually generate English Swedish words that were like in between, and it would. Like people were like, "What is that word you're saying to me? That doesn't exist." So they had those type of problems as well. So you might need these multilingual conversational skills in the large language models. Talking about racial linguistic gap. So in the second part of when we had the Swedish robots, 61% agreed that the robot understood them. So that was good, right? I mean, it's not amazing, but it's still like 60% thinks the robot understood them. And the speech recognition failures were actually only 4 interactions out of 28. So there were not many. And when it happened, it was mostly because of the Swedish names or places that the robot was mistaken. So you can, use different speech recognition algorithms than Google, for instance, like Whisper, or other types of algorithms that are coming up. Especially for older adults, because they have a different type of speech, like children have a different type of speech. Of course, there are different dialects and so on. People are saying, oh, the person from Skåne is not going to be understood. So you need to also have these both dialectual Swedish and other Swedish as well, for languages that are not that common as English in these large language models. You can also change your synthesizer so that you'll have these multilingual conversations. So when you're actually speaking in English, you need to be maybe switching to an English voice, but also you need to make sure that they sound similar. Then it sounds completely different. It's going to be very awkward for the user. Now, one more thing that actually didn't come up in the first part of the experiment, but it came out in the participatory design workshops, was the hallucinations, right? So let's see what it says.
Martinsons bok Mor gifter sig är en svensk tv-serie som gjordes 2011.
Jaha, jag trodde den gjordes 1979. Finns det två?
Nej, Moa Martinsons bok Mor gifter sig gjordes 2011.
Jaha, men då kanske det finns 2 tv-serier.
Det kan det faktiskt vara.
So actually, the person is right. It was in 1978, I think. There's no other such 2011 series, but the person dubbed it themselves because it's a robot, right? It should know everything. But these large language models, even if they don't know the answer, they're like this know-it-all person. They're not going to admit that they don't know the answer. Of course, they're going to say something, right? And then it's going to be wrong, and that's going to be concerning. So how can we fix that? So we had actually hallucinations in 11 of the 28 interactions, and 50% of the people thought the robot answered correctly to what they asked. And to improve the factual correctness, you can actually evaluate your uncertainty in your responses. So if you're not sure, do not say, right? Or you can actually reason to use the chain of thought reasoning or other types of reasoning to be able to understand if you're doing the right thing, they're saying the right thing. There's also, again, like memory systems, retrieval-based methods. You use a knowledge base and you're making sure that you're using that knowledge base and not something else, along with this attention mechanism for memory. And of course, as I said, we did not have access to the internet, so that's one of the reasons why some of these responses were wrong. So having that helps, and as well as a lifelong learning so that you can update your facts over time. And one final challenge was a very interesting one that doesn't really necessarily come up in these short-term interactions with large language models because it's, let's see.
Ja, det har vi. Vi träffas inte så ofta, men när vi träffas är det trevligt.
Det låter som en trevlig. Jag förstår.
Det var väldigt intressant. Den handlar om svenskarnas socialgruppering som fanns på själv i talet.
Har vi pratat färdigt då eller?
Det låter som ett intressant område att undersöka.
So as you can see, because the robot said "I understand," it's a conversation killer. You can't just, what can you say after "I understand"? Nothing, right? Just like "I understand," "I see," and that's interesting. Cool. Yeah, a lot of people that happened. This what we call the disengagement cues, that people did not have a response. Either they had to just try to like move the conversation forward, or they just waited for the robot to say something else so that it can actually move forward. So how can you actually do that, right? So keep the conversation flow. So you can detect engagement. So there's a lot of research on human robot interaction, shortly HRI, that's look into the engagement matters, either from the dialogue, you can do it against the gaze, you can look at the posture, the person looking away, maybe they're not engaged, right? So you can try to get the person back into and you can understand that you have made a failure and try to recover from it. And the other thing is you can keep the conversation flow, you can change the topic, ask the user what you want to talk about, and make the topic more enjoyable. But what is enjoyable, right? How do we know a person is enjoying a conversation or not? There has not been any research, even though there's a lot of research in user engagement, there's not been any research in user enjoyment in terms of beyond smiles. Because it's not just smiles that you can, smiles and laughter, they can actually show your enjoyment. There are multiple ways to show that you're enjoying a conversation. And that's why, and of course, there's user self-reported user perceptions, but they generally happen at the end of an interaction, so that you don't have this instantaneous response that the robot would need to actually recover from these failures. So that's why we created this human-robot interaction conversational user enjoyment scale, shortly HRIQs. So we gathered 3 annotators that have complementary backgrounds in HRI, based on our specific domain area. So one of them was an expert in user enjoyment. The other was an expert in older adults, working with older adults in HRI and cognitive science. And the third one was an expert on multimodal HRI and also cognitive science. So that we can actually try to find, determine a scale to determine what is enjoyment, given the complexity and the subjectivity of this measure. And they were all Swedish native speakers, so that they can understand, given the cultural context of a person, of this nation itself, by analyzing these videos that we had, of the videos that I've been showing and so on, these interactions that we had from the participatory design workshops. So they have defined the scale you saw as 1 to be so we started with actually a scale based on couples conversations and marriage, that enjoyment in couple conversations. And then based on that, we gave them 3 videos, one of them from the initial experiment with the English interaction that has more failures, so they can actually see that there would be more failures sometimes, and 2 from the other Swedish experiments that has less failures, but still also have some. And we gave them both at the beginning, frontal side video, frontal video, and then frontal and side video of the interaction, you're going to see in a bit. And then based on that, and the videos they have analyzed by themselves, they came together to discuss, to create this scale, and they determined from 1 to 5 what each of these levels correspond to. So the 1 is, for instance, discomfort and or frustration. If a person is having a discomfort, like showing discomfort, then you know that they're not enjoying the conversation at all. That's low enjoyment. And the second is boredom or interaction failure. And by that, interaction failure doesn't mean necessarily a robot failure, because robot failures can be funny. But this means a robot makes a mistake, or a person makes a mistake, and the interaction is disrupted, that it's not going well. And the third is politely keeping up the interaction, so they're continuing the conversation, but not really enjoying it or disenjoying it. And 4 is a smooth and effortless interaction, everything's going well. And 5, they're into it. They're deeply connected, having a deep connection with the robot, and are immersed in this conversation. So for what are signs of enjoyment? There, of course, these are contextual dependent, right? So these are only suggestions to understand what enjoyment can be in a conversation. So the conversation moving forward, there's a strain or discomfort. The person is asking questions to the robot, being playful, for instance, or sharing personal experiences, showing that they are actually caring about this robot and the conversation. And understanding a common ground, they have established a common ground, and they have anthropomorphized the robot as well. Then these are the textual things that you can get from conversation context. We're going to come back to why that is important. And there's multimodal cues, like there's a smirking, like smiling, laughing, movement, smooth turn taking, the dynamic tonality that the person will have. These are also showing enjoyment. And then on the other hand, there is signs of disenjoyment. For instance, in terms of the conversation contact, they might be tired, they might be having repeated questions from the robot, that might, as you previously saw, cause frustration, or the person or the robot might be trying to do topic closure. And on the other hand, there's more multimodal signs to detect disenjoyment. This is really actually important. So low energy, or sighing, or long breaths, or less smooth, flat tonality, or silence, one you saw before, and negative facial expressions, the flaring nostrils, or the disengagement cues, either looking away or saying, I understand, as well. But there's also the three, right? The neutral is a lack of these things. But there's also going to be cases when there is exchange, when a conversation turn an exchange as multiple of these levels. In that case, you can actually use either the dominant level, whichever has the most impactful thing in your scale, or break the exchange in between if they're quite far apart. So why is this? Let me show you an example of one.
Oh, I just wasn't sure what you meant. Are you asking why I didn't want to go with you?
No, I asked where you want to go. Do you have a favorite place?
So in terms of this, like you can see that the person is kind of frustrated because there's a speech recognition failure, and that has happened that before in the within the turns as well, and is looking at the experimental multiple times. So they're not engaged in the conversation. Let's not use engagement for enjoyment, but they're not into the conversation, right? So you can say that this is an example of one, that these are the example videos that we gave them, that they defined the scale on. And here's an example of two.
Jag älskar den unika stämningen när man ser alla båtar och haven omkring oss.
Det är riktigt.
The person gave an disengagement cue. And then a glum expression. So he was actually smiling at the beginning and then just went. So you can see that the person is bored, right? So eventually this is an easy way of determining that it's a two. Now let's go to the more difficult parts.
Det är bra att veta. Vad föredrar du när det gäller musik och dans? Mer klassiska eller modernt?
Ja, jag lyssnar nästan bara på klassisk musik och så spelar jag piano.
So you can see that it was just a normal conversation, right? It was a continuing. It wasn't that the person was like really into it, but it was like, I'll continue to ask me a question, I'll answer the question. So that was more of a the politely keeping up the interaction. And then we go into details. First getting excited.
Ja, den är ofta känd för att vara tung och influerad av de vilda naturliga landskapen runt Östersjöområdet.
Säger du? Det tror inte jag.
The person just frowned. Why is this a 4, right? Because they're actually having very smooth interaction. They're actually believing, they're anthropomorphizing the robot. They're like, no, I don't believe that. Why do you say that? Like, you wouldn't frown to you would frown to a person when you're talking, right? You wouldn't frown to a robot like, why do you say that? No, it feels like this is an ongoing conversation. And then finally,
Det låter som en härlig stund med din pappa.
Ja, det var det.
Han fiskade och jag låg och lyssnade på klucket mot båten. Det var bra.
You can see multiple styles. The person is like completely immersed in the conversation. And he's remembering a memory from her childhood. They went with fishing to his dad, and this was a really nice conversation. So you can see that it has to be defined as a 5. So basically, what they did this in this data set, and so after determining this scale, is to evaluate the scale on this participatory design workshop. 25 of the participatory design workshop adults that we have with the 7-minute conversations. So we had in total 174 minutes of conversations that correspond to 590 turns. So they were doing both exchange level, turn level, per turn, the robot speaks, person speaks, they rate the interaction, and also the overall interaction. After 7 minutes, what did they think from 1 to 5 the enjoyment level was? And we also had that we did not give them, we gave them after to discuss the user's self-reported user perceptions from the questionnaires that we had in the design workshops. So the user satisfaction, if the conversation was fun, was interesting, and it felt strange. And when we looked at the overall, all these 174 minutes of interactions, we saw the most common is strange. So people, one, have a more or less, the annotators more or less give a Gaussian distribution for everyone. And this is not just in total, but also per participant, more or less the same case throughout the interaction. And mostly it's just neutral, the enjoyment, because you're having a 7-minute conversation. You're not going to be super high all the time. You're not going to be super low all the time as well if you're not getting quite frustrated with the robot, right? So it actually makes sense that the conversations with the robot can be just mostly neutral. And when we looked at the reliability between them, we actually saw, like, we have 3 annotators, right? And they have different backgrounds and so on, which, you know, had them understanding some things differently, perceive some things differently. And so it was low a bit, the 0.47, when we looked at them in total, the integrated correlation, the reliability. But when we looked at their average of their rating, when we considered together 3 of them as a group, how do they perform? They actually perform quite well. So 0.72, they have quite reliability, which means that together the power is more important. So to have more annotators that can actually have complementary backgrounds is important. And we saw that 2 of the annotators, as you can actually see here, had more in common than one of the annotators throughout most of the interactions. And the annotator that was different from the others was the one that was actually background in user enjoyment. So they were perceiving it more positively or more negatively based on the enjoyment perspective, where others were looking more in interactional perspectives. And I said that, and the divergence, as I said, it was due to the conversation context. It was perceived differently. For instance, the laughter could be perceived as a frustration or an amusement from different parties in the annotators. And we looked at the user perceptions. We saw that there was only significant correlation with the perceived strangeness. So they were definitely trying to look at discomfort, that the strangeness that the people were having in the scale, are annotators. And the conversation context caused discrepancies. For instance, there were either transactional interaction that they rated it more highly than the person perceived, or more sensitive and controversial topic that the person was rated it highly, and they actually, according to the scale, they did not have a very good interaction, but was rated as low by the annotators. But they also, in some cases, of course, agreed with the annotators, the users themselves. So one final thing that we looked at was, okay, that's great. We define a scale. We can give experimenters a way to actually now define enjoyment. But let's also automate that so that we don't have to do it ourselves, right? So we looked into large language models. How can we do this? And there are several metrics. This was Andre's work that he led. But there were several metrics that we looked into. But now what I'm going to show is the balanced accuracy, which means that we're treating each rating equally, like 1, 2, 3, 4, 5, even though in the data set, as you saw, they have different numbers. So there's much less 1s and much less 5s. And much less 2s, but more 3s and 4s. But if you do it normal accuracy, then it's going to be that the models are trying to just put threes instead of actually giving ones or fives. But we care about ones or fives. We want to know when our interaction is going bad, right? So that we can actually fix it. So when we look at this with this balanced accuracy, the annotator's average is 0.37, and whereas the majority baseline, the threes, is 0.2. Now, we had several options. So we either gave the scale and the instructions. Remember the rating on the low scale, you need to look at this. Rating on the higher scale, you need to look at this. And the dialogue history, the example videos that we showed, two of them, two each actually. And the model could do reasoning. So the model could, we asked the model to reason before you give an answer, right? So give the reasoning of why you give the score and then give a score, which normally should allow the model to think about what it's going to reply and give better responses. And then we looked into the machine learning part, the supervised learning with multimodal features. So these large language models are mostly textual, right? They don't have these multimodal features. So we said, okay, we give them the multimodal features. Let's see how they do. So we had temporal features like turn taking, audio features like spectral frequency and prosody of the voice, and video features like face position and action units and expressions. So with XGBoost and LSTMs. So now the important parts. We'll look at 3.5 for Gemini with videos, the multimodal one, with XGBoost and LSTM. So I'll show the best performing models from all of these models. The very, very best performing model was GPT-4. Even though it did not have videos, it was actually better than the Gemini with videos. And it wasn't when it was fed all features that it was given the highest balance accuracy. It was actually that it did not want the instructions, that it did not want, for instance, the examples of the videos. When we were giving the examples, we were, of course, giving the transcripts for the textual models and not giving the multimodal cues in those transcripts. And when we were giving the reasoning as well, we gave the reasoning from the annotators. So yeah, that's great. GPT-4 is great. But let's also look into how they correlate with the user perceptions. So according to this, GPT-4, not the history reasoning that we had previously, it doesn't correlate with anyone, like with any of the user perceptions. But the one that has all features, that has the instructions, that has the examples, actually correlates in three aspects: the satisfaction, fun, and strangeness with the users. But keep in mind, the humans, the annotators, only correlated with the reversed strangeness. So the large language models looked more into more aspects, the satisfaction and the fun, even though they did not perform as good as the annotators. But given that, Gemini had the videos, it should be able to tell better how people perform, how people react, and so on. So was it bad to have these multimodal features? And even the LSTMs and so on, it did not perform that well in the previous, both in accuracy or with user perceptions. So is multimodal worse? No. Supervised learning, what we discovered was actually it mimics annotators. So it gives really good scores, but doesn't really understand. It overfits. That it just gives the distribution that the annotators are giving, mostly giving 3 and so on. Whereas the large language models, they actually have an understanding of the system. And this, because one of the reasons this doesn't work is because 590 turns, even though it sounds a lot, it's actually very low for these machine learning models. It is of course overfitting with the number of data that we have. So GPT-4, yes, is better in Gemini as a whole system for detecting user enjoyment. But if you look at that, the Gemini with all features is actually the green one with the video is actually better in detecting low enjoyment, detecting 1 than any other model. So we need that, right? We need to detect the low enjoyment so we can fix things. For instance, this one that we previously saw.
Jag förstår.
You remember? The I understand thing. So what did GPT-4 say about this? The person's question suggests a possible ambivalence about the continuation of the conversation, indicating either a loss of interest or seeking clarification on the status of the interaction, and gave it 3. 3 is the conversation is going, is politely keeping up the interaction, right? Whereas if you remember, we have the huge, long pause that the person is giving, that they're actually discomfort, right? And then when you give this to Gemini, the video to Gemini, they can understand that. The user appears to exhibit a level of boredom or disengagement with the conversation. The user's facial expression and tone of voice further supports this assessment, as they seem neutral and unexcited. So if giving just the transcript, the conversation context, is not enough. We need to give these multimodal features. But maybe because GPT-4 as a model was better than Gemini, that it actually performed better. But maybe the GPT-4o is going to perform even better now than all the models. And then it's actually, since it has all these now features that hopefully we'll actually try in the future, it will be able to make better assessments of user enjoyment than humans themselves, given our human-defined scale. So I am really grateful for all the work that I've done here, that I've just presented you, to work with Gabriel and Sarah, my supervisors. They've been really fantastic for the past 2 years. And I've also been super happy to work with my collaborators, Ida on the challenges and like gathering data part, and Andre, Yura, Sophia, Eric, Lubos, and Joachim on the user enjoyment part. And it's been such a great ride. And as I said, I'm gonna continue here with the turn taking. So now my conversational campaign robot might be continuing, but in terms of getting that turn taking better. And if you want to see any of those papers that I've just mentioned, all the described, they're all QR links here. And thank you very much for listening. I'm happy to take any questions.
I'm thinking about if you're lonely, you want some human connection or
Yeah.
connection with a sentient being at least. If I had a robot and said, I like broccoli and I like to go out in the nature, I know this is just bullshit, right? So, but on the other hand, it will engage me in the news. It might have process news, right? Or talk about politics, so we can have a discussion or something.
Yeah.
That I would be totally on board with that. But it sort of breaks this what do you call it? Suspension of disbelief when it says something which I know is complete bullshit. I think that this must be true for. Did you give any thought of what kind of personality you would give to the robots? It's like it seemed very random to me.
So in the beginning, it was more like based on the state of the art, saying like you want to learn more about the user. That was a personality. And the second one, the one that you had, like it was asking, like the users were taking more control of the conversation. It was because it was a empathetic character, that it would listen, actively listen to the person and provide social and emotional support. There was a companion robot, that it was more specific, that it would listen and like try to engage them in conversations about their memories, about their families. We actually gave them specifically as a prompt for the robot to talk about these things.
But what does it, I like broccoli too. What does that come from? I mean, that doesn't make sense, right?
Yeah, so that's just mirroring, and it's also like both doing mirroring so that it's it's good to trying to be nice so that it can get to be liked, I guess, and also it's these models are doing themselves anthropomorphism so that it's actually, even though we told them it's a robot, it can do this. And this was available in 3.5, the Da Vinci model, because we didn't want the robot to say, as an AI model, I have no feelings. It's going to be so boring to talk to the robot like that. So the Da Vinci model, it was more, these guardrails was not there. And then it was put on by OpenAI, so that now it's not that easy to actually have a response. I like broccoli too, but it's also important to have like this human-like connection, like you were saying. So you want the robot to be more anthropomorphic, but it depends on the person, because some people might like this kind of conversation. some people, as I say, were having a transactional conversation. They were like trying to generate a story with the robot and so on. So like they were asking for a recommendation for restaurants or their rugs, which rug they should buy and so on. So it's because it's open domain, it could be about anything, right? That's the best part of it, I think. Yeah, Gustav.
So I'm just curious, as you mentioned the ability to maybe equip robots with gestures.
Yeah.
And that is one of the areas I work in. So I was a little bit curious because your suggestion was to use LLMs to generate gestures, if I understood correctly. And sort of, I've often viewed LLMs as maybe if I like they're verbal or linguistic in some sense, whereas gestures are non-verbal or maybe co-verbal.
Yeah.
And so on. So we're often using, say, if I look at my research, it's mostly diffusion models and things like that. So what is the idea specifically using LLMs for that task?
It's more than LLMs, it's more like visual language models, I would say. That would be vision language models are going to be more appropriate because they need to be able to have this information that the gestures in their data set possibly to be able to generate things. So while I was referring to large language models, multimodal large language models. So in the other sense, there were, for instance, work from Gabriel and Chimaya. They actually generated like gestures on the face using large language models. So it wasn't even vision language models. So there are some work that works on that. And I think that's the possibilities, like you can maybe tell it to do these, what are the action units that the face should have for this for the smile, and it could possibly know that. The thing is, we don't know what's the data set, right? So, but the vision language models are going to be probably more appropriate, and I think the combination is going to be actually better, like the diffusion models with maybe these models that can bring about both sides of the equation to the.
I think it's
Yes, I do that. So the way you can do it that works pretty well actually is to you have the thing that the robot should say, and you put in anchors in the sentence, sort of boundaries, and then you say this is like the list of different types of expressions that the robot can make, and then can you choose from that list? So it might insert a nod or a shape or frowning and so on, and yeah, it's actually very good at that.
So that answered the follow-up question I was going to have about sort of how to put it at the right point in time.
Yeah,
great. Thank you.
Yes.
So this is about enjoyment, like measure of enjoyment. Do you think that also the quality of the content, so besides the visual cues from the participant, the context of the cues, do you think also the quality of user response is like useful for extract? Like if you ask me which is your favorite movie, and I can answer it's Harry Potter. But if I say, oh, it's Harry Potter because, then it's I'm expanding the question. This is also a clear sign of enjoyment, like I'm interested.
Absolutely. Like it's also the reason that we did not give like a more longer list. So we actually gave our annotators a huge list of things that they can look at, the multimodal cues that they can look at, but they selected a bit more to our context, as well as to the context that we did not want to limit the scale to saying this could be that, this could be that. But definitely it's like to talk more about the topic is to be interested in a topic. It's definitely is personally a sign of enjoyment. But for our scale as well, we have on the paper, in the HRQ's paper, that we suggested that if you're applying this to another area, like not older adults, but for instance, with young adults or I don't know, a home robot and so on. So in other application scenarios, or like an education robot, for instance, then it will be better to redefine the cues, not the scale, but the cues for each of those 1, 2, 3, 4, 5, so that you can actually say, given your task or given your domain, what are the cues that you should be observing in this with the experts in those areas. Yes.
You talked about the GPT-4o model.
Yeah.
And maybe some of the problems will be solved, but what do you think still remains?
Good question. No, for good questions, but we still weren't able to test the model. So from what I saw from all the demos, The turn taking is okay, but not very good. So there were actually parts that the agent had interrupted the person, even though they were about to take the turn. So that might be good to improve. Hallucinations, for sure, is going to be the biggest issue of large language models. Disengagement cues, I do not think they actually looked into that. So like this enjoyment thing and so on. So that's one thing that's will be very important for people to look at. What else? And yeah, personalization. So memory, they're looking into it slowly, but to use that memory over long-term interactions, not just for like 5 sessions, 10 sessions, over a year, is not something that's easy, and that's not something that most large language models actually are not targeting at. So personally, that, as I said, it's my area. I love doing that. The lifelong learning, continual learning in the models, and to personalize is really important if you're going to put the robot in a person's house for a long time. If you're going to put the robot in a school and you're going to have the children interact with it all the time, because people expect the robot to remember when you see it for at least for the second time, or the third time, or the fourth time. So that's something that I think the large language models should definitely focus on if they want to have these agentic models like personal assistants on our phones or these personal robots to talk with. Yes, sir.
Thank you so much for the talk. I have like a very practical question now. We have like participants that come in and collect their audio and video, and then we send it to Gemini or So how do you have any advice how to go about this? Were you very open with them about it, or was it in this first exploration maybe not so much, but in the future you're gonna address that differently? What are your thoughts? Like, what do you advise us if we wanted to do like some, like experiments or use LLMs? Or like any visual language model or something? What was your learnings in that side? Just been like handling, so to say.
Privacy protection. So yeah, definitely. So our users have asked about it, and they were actually concerned about it. That's why we have we have these design scenarios prior to their interaction, and we have tried not to stir them in any way so that they will not be biased by their with the scenarios towards their interactions. But for future purposes, so we were sending the data to GPT 3.5, and we have asked them specifically not to talk about sensitive issues, just in case. For GDPR reasons, as well as for their own safety. But these privacy preserving machine learning algorithms and is actually one of the best ways to deal with this. Of course, as I said, onboard systems are not realistic for robots. Otherwise, I would have definitely suggested to use the robots, the Llama 3 or Mistral on your own system. If you can have a computer next to the robot, then you can it will be both faster in terms of the generation time. So because you're not battling against other people on the server to get a response, as well as if you have a good enough GPU for that, of course, as well as you will know that the data that goes is going to be on your own system, and it's not going to be used by any other person for data purposes.
Last question, like about the turn taking this time. So how much these challenges that you encountered you think are due to the technology limitation rather than, I would call it like research approach? For instance, if the robot is slow in understanding and answering, and then you're searching for some pillars or for some like channeling, but the robot is just reasoning on what to answer next. That could be, of course, like for instance, for speech, Google speech recognition module. But then, for instance, 1 year later, Dialogflow comes and just got to know recently, and Dialogflow allows you to capture a stream through the audio, and until it doesn't detect a content, an intent, then it's not going to answer. So it could avoid, for instance, the problem of like the person speaking, then stopping for a second, but there is no, he knows that it's not finished yet, so he's going to just keep listening instead of interrupting. So I think some of them, for how much we can try, to try to avoid the problem. The problem sometimes is still that there is no the technology for having this kind of interaction as we are having. So what do you think about it?
Yeah, absolutely. Like Gabriel and Eric's model, they actually are quite good at it. So that's what I'm going to look into for turn taking with the human robot interaction. Because what Eric's model was that it would actually determine when the person will about to take the turn. So that it would actually wait out if it was just doing like and so on. So it will wait out, and it wasn't doing intent recognition. It was actually not textual as far as I know. It was the speech prosody that it was using. So it's possible that to actually combine both the textual responses and the speech prosody to make perhaps a better turn-taking model. But of course, it's not going to be as natural as we are as humans. And as well as I said, like, for instance, when we get interrupted, we could actually reconsider our response to give, right? Like we're really immediate in trying to generate another response given what you have just said. You might have just changed my mind, or I might have misunderstood you, and then what you said can just immediately change what I'm going to say. Whereas with the large language model, it's also difficult to say. So you're going to say something, you didn't say it because the person interrupted you, you're like halfway through. What do? Do you say the rest of it? Do you change it? Do you go back? It's also difficult to do that, the change. So what is the right way to do it? It's also challenging to find. But definitely technology is hopefully gonna get there. We're going quite fast. Like this was like 2 years of work, and in the meantime, things are coming up. I'm like, okay, I've been adding paper to the paper like this. The challenges paper that I presented is like actually 70 pages. So it gets more and more bigger as things are getting better. But it's also good that we can actually have these models running on real time to talk with humans.
You briefly talked about like personality and the fact that like Julia Rhodes thought that the robot didn't have personality overall.
Yeah.
But like I actually thought that like about the voice tone, because like the personality comes out in a way through the voice.
Absolutely.
And if it's like monotonous, like it's not engaging, especially for the adults, they were trying to emphasizing also their voice to be more engaged. I mean, like, to be more engaging and understandable from the robot.
Yeah.
Like, did you thought about it?
Yeah, you mean, so the robot's voice was definitely a problem because they were thinking it was dull, that they did not want to probably engage with the robot because of that.
Yeah.
But they also adapted, so especially in the first experiments, because they were speaking English and the robot kept on interrupting them and so on, they were trying to change how they interact with the robot. Because like the younger adults know how to interact with these spoken dialogue systems and robots, right? We need to give like short sentences, we need to be really clear. But they were talking as if they were talking to another person, and they were expecting that, right? Because they see on media like all these robots that are quite advanced. They're not aware that they're actually not fully autonomous. But that's what we need to give them. Like they are expecting this robot. We need to give them this robot because otherwise they're not going to interact with it. Yeah, definitely. So they were actually telling us that it was difficult for them to adjust in the first experiment. But in the second experiment, we did not have such comments as far as I remember in the interviews. But it was quite smooth. Like I said, like especially the Swedish helped. The fact that we did really small changes. We changed the prompt. I don't know if you had noticed, but we put a red light underneath the robot for the turn taking. We changed so much. Like it got the robot so much better that we said the robot would have a red light, meaning that the robot will not hear you. So people they were not interrupting the robot. In the beginning, there was no red light, so they didn't know when the robot was listening or not. In the second case, they knew. Also, what we did not tell them was the gaze away. So if you, maybe if I can show you, yeah, so when the robot's thinking, it looks away, right? So it's red, and it looks away. You can see it looks away. So we put that so that it looks more natural. The robot's thinking something. We did not tell them that's going to happen, but it's more that they can actually feel that it's more natural, and where it's like otherwise, look in their face and think and not respond will be more awkward, for instance. So yeah, that's probably one of the reasons for the turn taking and interactions were more smoother. Any other questions? I'm sorry I took much longer than I should. I hope you enjoyed it. Okay, perfect. Any questions online, by the way? Happy to. Oh, yeah, please tell me.
Hey, thank you for the great talk, Bahar. I had a question, like theoretically, how do you see the difference between engagement and enjoyment?
Oh, well, that's a difficult one. So we try to keep them separate, the engagement and enjoyment, and then in that, so you can be engaged in a conversation. You can be like really talking about something that's you're not enjoying, but you're like versus discussing, arguing or something, but you're not enjoying the conversation, right? You're not having a happy time with the conversation, you're arguing. So that's our stance was towards engagement and enjoyment. That there can be that if you're enjoying a conversation that you can be engaged in a conversation, but your engagement in a conversation not necessarily means that you're enjoying a conversation.
So the objective of a social conversation is always enjoyment?
Not necessarily. If you want to discuss with someone, then it could be engagement. It just depends. It's context dependent, right? So if you want to have these like casual conversations, then you probably want to have an enjoyment in the conversation. But if you want to discuss with someone, that was your aim, then it's okay to be engaged in a conversation but not enjoying it. So it's very context dependent. In our case, we were trying to make it more enjoyable. Like we want to make it more enjoyable for older adults to use this robot, but yeah, it could be that you don't need enjoyment in your interaction. Then it's more about the language.
Perfect. Thank you so much. I know it's too much, but can I have another question?
Yeah, absolutely.
Yeah, how did you come up with those like sign of enjoyments in one of those slides? I think if you go like 4 slides back.
Yeah, definitely. It's here. So so what we gave them was we gave our annotators a list of multimodal cues for enjoyment or engagement within the literature. And from then we asked them to come up, choose what are the relevant ones for enjoyment for this task, as well as if they have other cues that they have found, that they have seen in the first 3 videos that we gave them for alignment, to add them as well. And they're like, if you want to know those literature paper they're referring to, it's in the paper.
Yeah, sure. Thank you so much.
My pleasure. Anyone else? Okay. Great. Now I can close the session. Thank you very much for coming. Bye.